Hello all, welcome back to the theory session on the topic DBSCAN algorithm. And most importantly, we are going to see two key terms, how that epsilon and min points plays a major role in DBSCAN algorithm. And the expansion of DBSCAN algorithm, you can call it as density-based scanning method or density-based spatial clustering of applications with noise. Clustering based on density, such as density connected to points. So that is local clustering criterion. By that we are going to use in DBSCAN algorithm. DBSCAN especially used for majority case it is used in data mining and data retrieval purpose. K-means algorithm is best suitable. It's a linear type of data sets. K-means algorithm will suit. But for the data sets have curved data points, over there the K-means algorithm fails. So the K-means cluster algorithm assign points to the nearest clusters. Sometimes it may fail, right? In order to overcome that, we are using a DBSCAN algorithm. So DBSCAN algorithm works on how many samples are there in a particular unit area. So in this case, if you look, you have two clusters. Cluster 1 is blue color and cluster 2 is red color. So right, so you have a huge gap between the cluster 1 and cluster 2. So if you ask your DB K-means clustering algorithm, it will form a cluster like this. So your K-means algorithm fails. In order to overcome that, we are going for a density based method. How the density based? If you see in these two cases, in particular cluster 1, this is considered as red, you have high density area. So your points will move with the nearest neighbors you have based on the density, and it will form a cluster. This is cluster 1, and this cluster 2 it will form for the blue color, and you can be able to see some green dots over here, and some data points are something missing. That is in comes under cluster 1 as well as in cluster 2. So those data points are none other than your noises or outliers. So in DB parameters, you need to focus on two parameters. One is epsilon, another one is minimum point. Epsilon, you are going to have maximum radius of the neighborhood. That means you are going to draw a circle with a radius of r. Right, with a radius of r, you are going to draw a circle. That r is nothing but an epsilon. In that particular unit area, how many data points you need to consider? So that if how many data points if there is present, so you will consider this circle as a core cluster, right? Consider if a minimum point is 3, so center you have one more data point, so here you have one other data point. So minimum point is 3 means you can consider it as a core cluster, right? So in this case, how many data points are there? 1, 2 and 3. So you can consider this as your core cluster. Fine. That is the difference between epsilon and minimum data point. So minimum data points is minimum number of points in an epsilon neighborhood of that particular point. So n epsilon of p, you can say it as q belongs to d given that distance of p comma q is less than or equal to epsilon value. We have some other data point is over here, you can't consider the data point, it is an outlier or noise. So within the epsilon radius, you need to count the data points. So we have reasonable data points less than or equal to epsilon, you can consider all those data points that belongs to n epsilon of p. And directly density are reachable points. You have two things. So the point p is directly density reachable from a point q. You have two data points p and q with respect to epsilon and minimum points. If p belongs to n epsilon of q and core point condition is n epsilon of q should be greater than or equal to minimum points, right? So consider you have a q point over here and minimum point is 5 in this case and epsilon is 1. So with 1 centimeter radius, I have drawn two circles of p and q. In this case, we need to say whether point p is core point or q is core cluster. So in this case, q, look at the q, you have nearly is more than, if you consider q, you have n number of data points more than 5. It exceeds more than 5. So this core point condition is passes in q. But if you look at p, including the center point p, you have only 4 data points. Even though you have borders, we can conclude that, but it is less, so it doesn't comes under core data point. So in DBSCAN there are density reachable and density connected. First we can see what is going to be density reachable. You have considered 2 points Q and P. You have Q and P. From a point Q, the point P is density reachable. From where? From Q. If there is a chain of points, you have n number of chain of points P1 to Pn. Consider it as P1 to Pn such that Pi plus 1 is directly density reachable from Pi. Fine. Pi. Fine. This is a not symmetric one. So it is the next one is density connected. See here, we have point P over here and point Q over here. Fine. So point P is density connected to a point Q with respect to epsilon comma minimum point. If there is a point O such that both P and Q are density reachable from O. From O with respect to two conditions. One is epsilon and another one is minimum point. So in this case again, here clearly mentioned, you have three points you need to note down. One is core point, another one is border point, another one is noise or outlier. A core point is has more than a specific number of points. Specific number of points, that means it is more than minimum points or equal to minimum points within epsilon radius. These are points that are interior of a particular cluster. In this example, you can consider this as your core point. Minimum points you should have 5. Again you have 6 data points that is inside the cluster. So you can consider this as a core point. So what are border points? So this is a border point. How? Border point has a fewer than minimum points. It is less than minimum point. In this case it is 2. Actually you should have 5, but in this case you have only 2 with epsilon radius, but is in the neighborhood of a core point. This is a neighborhood of the core point. You can consider this as a border point. And some points will be an outlier. It's any point that is not a core point nor a border point. You can consider all those stuffs as a outlier. And here is another example for you people to calculate. Check how many core points and data points are there in this case, right? How many outliers too. Thank you.